mean, not bad, right?
It works.
A little 90s grunge vibe or something, I don't know. All right, everybody. Welcome to another episode of Cumulex Radio. I am your host, as always, Josh. And as always, Aaron is on assignment doing more important things on site, helping customers while I sit here and make videos. Joined with a really awesome guest today, we have Chris Clason, the co-founder and CEO of Deep Perception. You're going to hear the word AI probably once or twice in this one, but just give everybody a quick warm-up here. Introduce yourself and, what is Deep Perception?
Sure. So Chris Clason co-founded Deep Perception with Alex, my co-founder that I met here in Austin about a year ago. And we've been we're focusing on bringing video analytics to the masses. So there's all kinds of interesting AI stuff happening, but I think really, the opportunity is how do we get this in the hands of, your average user? So there's, all the cool AI stuff, but really what we're focused on is packaging it up, make it so it's easy to install, easy to use. And it's one of those things that you enable and it just works and you don't think about. And I think really that's the challenge with AI today is more about the deployment. There's always the cool bleeding edge stuff, but getting it actually usable and something that, the average person can use, that's the real challenge today with AI. Not just video analytics, but AI in general, I think.
No question. Now, and of course, you bring a tremendous wealth of experience into this new. I don't know if you're allowed to mention your previous employment.
Oh yeah, no. So yeah, a bit of background with myself. Like as a kid, I used to always take stuff apart and try to figure out how it worked. And my dad hated it, right? Because the VCR would be busted up. And the thing is I fixed it. It works better. Built my own computer when I was a kid.
Right.
It was 10. I think it's 386 was the first one I actually built. Computer before, but. Background, various tech things. Started my career doing network, sysadmin network stuff, did kernel level BIOS stuff. Worked for a company, Authentic, which is where Touch ID came from. Apple ended up acquiring that company. I ran the field sales team, lived in Asia for a bit for them. And that was one of those other ones where it was fingerprint reading technology, okay, fairly well understood, but, mass adoption. How do you actually get it usable? We had a vision at Authentic, Scott and Larry were the founders. Their vision was always, let's take this huge fingerprint sensor. At that time, it was a 2-inch by 2-inch square. But the vision was always, well, let's get it into the button on the iPhone, from almost day one on the company. And then how do you get the software all that usable? So for me, that was great because it's really cool tech, but then also focused on mass adoption. Worked for Dell twice, doing laptops, video drivers stuff. Second time around was really interesting working for Dell DCS, which was their custom group doing data center solution stuff for customers like Microsoft, Facebook, and other hyperscalers, which was neat because we got all the power of Dell supply chain. So really good volume pricing, but then we had the flexibility to build custom stuff. So we would get all the commodity components at great prices leveraging Dell, but then we'd work directly with some of the manufacturers in Taiwan or US to build really optimized things for hyperscalers that had very different needs than typical PC manufacturers. Did some software stuff after that, got away from hardware, worked for a cloud company, Mirantis, doing OpenStack and later Kubernetes. They acquired part of Docker's business fairly recently. Did some fintech enterprise blockchain stuff. So again, another emerging technology where really cool tech. How do you actually make it usable? You can see a pattern here, right? It's really cool tech. How do you actually get it consumed? Did my own thing for a bit, trying to do something real in the crypto space, which I'm happy to talk about. It didn't go so well. We're trying to do something like price and tokenizing them. I think that was one of those where we had the tech idea, but didn't really validate the market well. Good learning experience, good startup, I guess, to kind of get that out of the way. And then Deep Perception is what we've been working on for the past year or so.
Wow.
So, big background all the way from hardware to software to embedded stuff to hyperscale. So I can jump around in this.
That is quite a journey.
Yep.
I learned how to read and I started hanging cameras. I mean, I got a pretty boring background compared to that, but no. So listen, obviously you've been through, mentioning that journey, all these different types of new tech, or sometimes, it's bleeding edge or leading edge, depending on how ready it is. I mean, the big buzzword, I think really everywhere on every type of platform is AI. So, I mean, I'm sure someone with your level of knowledge, I'm sure at times it's maybe frustrating to hear the way some people talk about it. I mean, how would you really describe AI. What is it really? What does it really mean? I mean, how do you think that compares to maybe the way the public perceives it, and maybe how they misunderstand?
I think, public in general is, AGI, right? Like, it's general intelligence. It's, AI is taking over the world, Skynet. Like, that's the way that I think public is very much like, AI is smarter than humans and we're doomed is kind of how, like, I think people start with that. My view of AI is much more, I think, practical. Like, AI is, something that augments or assists what a human's working on. To, like, you get insights out of information, you get told something, or you get something that is useful to you that saves you time from having to go manually sift through it. So I think, like, my bar for what is AI is quite low. Like, it's just something that's useful. That is, like advanced pattern recognition, whether it's an LLM summarizing a document. I think it's just an evolution of machine learning, evolution of analytics. It's, that's AI. I think, the public, is AGI is like, okay, if it does happen, or when. I'm still not sure if, I'm on the fence and happy to chat more on like, the current state of AI and the push towards AGI.
AGI is how Joe Rogan thinks of it.
Yeah.
Right? He's like, it's Skynet. It's going to think for itself. It's going to take over. It's going to lock us out. That's not really what AI is now.
It could be, right? But AGI has always been 10 years out, and it keeps pushing out, right?
Always 10 years out.
It's always 10 years out, right? So that being said, there's been a ton of progress towards, I think, more powerful artificial intelligence. Lots of talk around LLMs, and I guess just like conceptually, my issue with LLMs is like, please don't let this be what AGI actually is. It's like, please, I hope there's more to intelligence than just like really advanced pattern matching, right? So that's kind of like, I hope like AI evolves and there's something more than that, but maybe it's just doing a bunch of matches and whatever at scale. Yeah. So the hardware's changed really to support like these mass data sets. But again, like, taking a step back, like, I just really hope that AGI is something more elegant than what we have today.
No, and this will be my flavor of, I stayed at a Holiday Inn Express last night, but I got super curious about AI last year and took an online course from Duke University about AI and AI product management. Joke was on me because it started off with models and actually doing regression tables, and I don't have that many fingers and so forth to count with, but I did pass. I got a B+. I was actually super proud of that. But, because I always looked at what we were doing and I felt, okay, well, it seems like it's more about they're taking information that already exists and then helping you get from A to B much more efficiently. So I didn't understand how that would compute with, I agree with you. I think a lot of what I would hear was almost in line with what AGI is, which that course covered. What are these different? So essentially, it's, we have better hardware now. We have better compute. We have, increased the capability of taking these models and then scaling them. So, you have the machine learning, and then you have the neural network, and now we can actually scale with many, many nodes of these neural networks and just compute like crazy. But it's, it feels to me like what I don't think people understand, or you can tell me if I have this wrong. I mean, the data scrape is real, right? So they're going out there and they're scraping all the publicly accessible data, or in the case of Adobe, which I use, they're taking our photos and our stuff to train it. But they're taking. I think
Adobe just changed their terms of service, I think. But yeah, I get what you're saying though. Like, I don't think
it's a thing in the creative world. Yeah. They used. There's a lot of things that look like things that people actually did that are now available on Adobe stock, but that's a whole other part of it. That's the ethical, I guess, part of it, the ethical concern. But in the end, it's not really thinking for itself. It's not creating something new, but it's taking everything that's available and giving you something faster. So Google made it easier to find things with the Google search, but this is not that. This is saying, okay, I can quickly just sort through all the information that's publicly available, and I can give you a result. And that's kind of how I see it.
Well, I think like looking at Google search, right, you're able to find the information a lot faster. I think what like LLMs and some of the current Gen AI, it's like, okay, now that I have all these documents, like give me a summary of them. So like instead of having to read a 600-page report, I can have an LLM synthesize a page summary, and then I know whether or not I want to read the full paper. and hopefully I'm smart enough to know if the LLM actually got stuff right, because I think that's one of the biggest challenges today, right? Is LLMs are confidently wrong, and unless you have some domain expertise, a lot of times you just it's you got it back, it's truth, which I think a lot of people the internet said it was true, right? Like now it's the LLM said it's true. It's the same kind of phenomenon that I think happens with any new technology. People blindly trust it until they realize that they're not perfect.
And sometimes that's a hallucination where it doesn't have the answer but feels compelled to give you the answer. Yep. But honestly, I think sometimes maybe it doesn't understand what was a hypothetical, or in some cases there was an attorney that found out that it used movies and concepts around movies to build case law. Those weren't real cases. So yeah, I still think the human is very important in this, but I think that my personal viewpoint is whatever you do, I think you're making a huge mistake if you don't use the AI that's available, because you need to do what you do faster or you're going to fall behind.
Agree. I used to program way more than I do today, but tools like, Copilot and ChatGPT allows me to do really quick prototyping and test stuff out. So I'm way more productive helping my engineering team. But I understand the concepts of what I need to tell the AI and what I expect back. And I'm smart enough to realize if it gives me something that's just crazy or, can debug stuff, but ask me to write a front end UI for something, I'd look at you. And, even back when I coded, I used to hate doing front end work, but now I can get a prototype in 2 minutes. It's quite amazing. So productivity there is great. Another example though, it's we were trying to convert Docker Compose files over to Kubernetes deployment manifest. And we'll just throw it into ChatGPT, see what we get back out of it. Gave us back something, and it was confident on something until you questioned it. It's well, wait, doesn't this need to map to that? And said, oh yeah, you're right. Here's the correct one. So unless you knew what to look for, you would just take it back. And honestly, a few people that are quite good at Kubernetes got the result and were scratching their heads why it wasn't working. And then it was of course, these two things don't map. No,
the good news is it took that good information you gave it and helped your competitor, I'm sure.
Exactly. Yeah.
That's how it works.
You mentioned too about using existing data, and I think this is copyright law in general. What's a derivative work? What's considered a parody, whatever. So there's all this interesting legal stuff, and this is another thing. I love law and legal contracts for whatever reason. I've always been involved in complex legal deals, and a lot of my friends are lawyers. I don't know what that says about me, but
it says not to mess with you. Is what it says.
They're all M&A lawyers and don't come after my patents, I guess is what they say, right? I got good friends in that space, but looking at what you're allowed to scrape and use, what's considered public domain, what's considered for use. This is something that is happening at the country government level, right? Japan is trying to attract more AI companies, and by essentially loosening the restrictions on what you can do with stuff that's out on the internet. While other countries are trying to protect existing IP or creative people. So what's considered fair game for training AIs is it varies depending on where you're at, and Europe is kind of handicapped a bit because they're pushing back on what's considered fair use and what rights you need for training. Which who's telling you what's wrong or not? The Silicon Valley way is just move fast and let the lawyers deal with it later, right? Which is I think what we're seeing, in the U.S. today.
I think there's two sides to it. I think that this actually is a great benefit to society when used properly, when used responsibly. But it is, like the Adobe example. I mean, it's a real shame what's happening to some of the graphic artists and photographers that, that essentially they did the hard work. It wasn't exactly big income for them anyway, but then Adobe used that to train its own AI and then create very similar stuff at scale and charge the same amount and kind of squeeze them out. So there's two sides to the coin. And I think that's hopefully, I think we'll find a good, compromise. I think tech just moves so much faster than our government, in terms of creating laws. And I think that's probably always going to be the case. And maybe this one got further in front maybe than anything ever has. I mean,
I think it happens with every new tech, right? And this is, love it or hate it. This is what Silicon Valley does, right? Is, just break things and let the lawyers sort it out after the fact. I think the real issue here is these foundation models take so much compute to train. You need to, have billions of dollars these days even to play. So like you've got 3-4 countries maybe that have the infrastructure necessary to compete. And now you're looking at, well, okay, we need power for these. So now we're talking about like, okay, we need to, get power treaties with Canada or whatever. So we're talking at like that level of scale here, which, my first exposure to this was working for Facebook, right? Where we're, trying to find power in the hundreds of megawatts. That's, hydroelectric or, friendly power that also had connectivity. So like most people don't think at that scale. The problem is here we've got these AI companies training these foundation models that are sucking up everyone's data, but they have so much power because you have to have that level of scale to be able to play in this space. So like that's where how do people feeding into that machine still get compensated fairly, even though they're not using their own data to train models. So this is an interesting thing, and we'll see how the laws get on this.
Well, somewhere there's somebody that works for the government that's writing that into ChatGPT right now, looking for the answer.
I'm sure we'll get back a wrong one.
So, I mean, obviously, like we talked about, this is not AGI, but, I don't want to go down a political path here. Maybe this is more of a socioeconomic, but there is a decline in population that is occurring. Yet our economy must always grow.
Yep.
I mean, I kind of feel like as long as the robots aren't going to kill us, I think the idea of having, autonomous, AGI sounds like it could be a problem solver for humanity in the long run, because we are now having our largest generation of people are now leaving the workforce.
Right.
And really that was starting pre 9/11 or COVID, and then obviously accelerated throughout COVID. So, I mean, I'm excited about the thought of that. Do you have any fingers into that side of it? Do you hear anything? I mean, do you have any thoughts on when we may see that AGI become real? I mean, is that kind of what Boston Dynamics is working on with those robot dogs and so forth? Are they looking into AGI or?
Well, I'm not sure I'd consider that necessarily AGI, but it's, using robots to offload physical tasks. So in general, like technology has always been used to make production more efficient, from assembling cars, like even before, like now you've got machinery and an assembly line versus, individual stations. So like increase in productivity, I think is always going to be a thing. The question is, can you use technology and still compete with, cheap labor that's brute forcing it? So that's, I think, the real question. Like, Japan's been having a declining population, economy's been declining since before, and they've spent, invested a ton in modernization, whether it's robots actually helping people or trying to just, either do manufacturing more efficient or target that, top end of the manufacturing where it's, high end premium, high quality stuff where they can differentiate themselves from the mass market, mass market manufacturing that you get in other areas. So in the US, I think it's one of those things too. It's like technology, can we, be more self-sufficient and not need to import things? And can we, compete with other regions that have lower cost labor forces by, being, smarter with technology to manufacture goods? So I think that's the bet that we're making and we have to make. Whether it'll be successful or not, we'll see. That's going to play out over the next probably 30, 40 years. But I think in general, becoming more self-sufficient, leveraging technology versus being dependent on, foreign cheap labor. We're not, the US is not the only ones, thinking along these lines as well. So.
Well, and that's what worries me personally a little bit is, first of all, I think we learned during COVID and the supply chain crisis that occurred, we wanted everybody to have certain PPE depending on their occupation, yet that comes from China in many cases. China needed it too. There was a real backlog in trying to get that stuff here. You talked about Japan. I mean, China had a one-child policy for a very long time, and I don't hear it mentioned a lot, but I think they're on the cusp of being in a much tougher place than Japan. and we depend on quite a bit of our manufacturing really is imported from China. We want to reshore because we feel that it's good for us, but also I think we're going to have no choice at some point.
Right.
I mean, they're going to have limited capability so I guess my point would be, I do hear people say, and again, I think it's a misunderstanding of what today's AI is, but I would personally kind of welcome that AGI. I think it's going to be I think we need that. I think we're going to need that to continue to grow our economies and to reshore and to do a lot of the things we need to do. And let's be honest, I mean, none of us are teaching our kids to go work at the factory. If these factories start coming back home, I mean, it's a struggle to find people that are looking for that type of work, right? I mean, that isn't what everybody's goal is. Not seen the same way maybe it was in the 50s, 60s, 70s. So
the same arguments being made today is like, do people need to learn how to program, or do they just need to learn how to prompt an AI instead, right? So
right.
Like, we're seeing interesting arguments on that side. I still think it helps for people to understand what's behind the curtain, but like I think the challenge there is we're developing AI systems now that are so complex, like we're not even sure how they work. Like it's we're kind of reaching that tipping point where you put in, you get it, output out, and it's a black box, and people scratch their heads on exactly what happened there. So, like, anyway,
I work around software developers. I'm not saying that's happened here, but I've worked at some companies where I'm not sure that engineering knew what was going on, and they did it. So,
fair enough.
There's always a little mystique as the layers of code, get built. But so, what do you think? Obviously, we know each other because one of the things that you're doing is working on really great analytics for the security industry, and working with AI from that perspective. And for those of us that have been around a long time, I mean, we remember the early days of analytics where honestly, they didn't really work that well.
Okay.
But over the last few years, I think analytics have really changed in our industry, where they're seen to be very accurate and very helpful, and the adoption rate is just skyrocketing. So, I mean, from your perspective, what do you think has led to these analytics working so much better?
So, analytics, taking a step back, they're either run on the camera, which, limited horsepower to run, which I think may have contributed to some of the, performance issues, at least in the earlier generations. Some of the, the latest, camera AI chips are actually, quite powerful. Then there's, of course, let's ship all the videos to the cloud and process it there, which, works well. If you've got the bandwidth to support it, and, you've got the money to pay for GPUs running on Amazon or Google or whatever. I think what's really, though, kind of what's going to drive the adoption of analytics is, and why they're working so much better, is more efficient ways of running analytics close to the camera, at the edge, on premise, whatever term you want to use. And what we've seen are, newer chips optimized for inference. So, the thing that actually processes the video frame and, does the, is this a person, or more advanced things. Those chips have come down in price. They're extremely power efficient, which means you now really aren't necessarily limited by the AI capabilities. Now there's other limitations in the system you're designing around. So like before, you were like very limited on the actual, AI model or whatever. Now those perform quite well. Now it's all about how to actually get the video into these chips, do the processing, do like a level of insights on top of it, and feed it back into the existing system. So it's become much more of a systems problem than an AI problem. Where I joke with my team, we're like GStreamer is like a media framework, and we're a GStreamer orchestration company, right? Because we're like orchestrating where the video feeds come from, where do I resize stuff, do I offload stuff to the Intel GPU for decode? Like there's all this other stuff we do, and then the AI thing runs over here in the corner. So I just think that the models have matured. The computer vision models for doing like object detection and tracking, like those algorithms. They've been around for a while. A while in computer terms is several 5-10 years. So those are mature. They're battle tested, and then you have hardware that's optimized to run them now. So like you're not making the trade-offs like the hardware is so expensive. Let me see what I can cut down on the software side. Now it's almost like I've got unlimited hardware to work with. How do I build a system that performs appropriately?
Do you think that the future of our industry is going to look a lot like Chat GPT in some way, where the LLMs and the NLPs are, where that chat style interface where you're conversing with the software versus maybe just going to all your different checkboxes and doing what you need to do? I mean, do you think that maybe that is the future of how things are going to look, or do you think that's maybe a flash in the pan and just how we interact with it at the moment?
So I've got to make sure my Google Home is turned off for the example here, right? So I think it's going to be not a full replacement, right? But like, okay, I've got a light switch on the wall, or I can tell my Google Home, okay, good, Google Home to turn off all my lights, right? Like if I'm near the light switch, I want to do something quick, I hit the light switch. And other times, like a different interface makes more sense. So I don't see, NLP, LLMs completely replacing drill down searches. Like drill down searches are extremely efficient. Mm-hmm. They're it's kind of a natural thing. You can see things very, very quickly. It's kind of like almost like building the drill down and seeing how things get filtered in and out. Like that's part of the benefit, right? Versus throwing something in a black box, getting results out. That being said, I do see, NLP, LLMs being used for synthesizing the results. So whether that is, me asking a more complex query and getting results back, or something that's even more proactive, right? Where stuff's running, and every day at the end of the day, I get like an anomaly report. It's like, oh, you had 7 people more in your store than usual on Tuesdays. You had one person waiting in line for over 7 minutes. Like that kind of stuff, I think, is where the future is going to be. It's less of replacing that human interface, but more of like giving me those insights in different ways to consume. Am I, using the Alexa versus light switch thing, like, it drives me nuts. Like people are sitting there yelling at their Alexa when they could just like turn the lamp off sitting next to it. Like I feel like people have over rotated to using ChatGPT style interfaces for things, but for like more complex things where you just want to fire off a complex question and get a result back, it's great. But it's not going to replace traditional interfaces in a lot of cases. I think it's going to be, pick the right tool for the job kind of stuff.
Are there any like really amazing things going on in the world of AI that nobody's talking about?
Let's see. We've been very, very focused on computer vision. Like, people are talking about it, but it's the zero shot, like things like Clip, right? Where you can feed in an image without, the model hasn't been trained specifically on it, and get quite detailed descriptions from it. Microsoft's Florence 2 model, for example, you get quite amazing results back from analyzing images, like detailed stuff. Like I've got a picture of my cat, or cat wearing like an R2-D2 costume, whatever. Like it's like completely ridiculous photo, fed it into Florence 2, and it like summarized like exactly the breed of the cat. It was wearing a costume. It was R2. Like it was just incredible that I was able to get that level of detail out of just a random picture. So I think for people that haven't played with them directly, like the actual power and the accuracy of the current models, and I'm talking like past 6 months. Florence 2 is relatively new. It's incredible how detailed results you can get. But then for like 9 out of 10 are great. Then 1 out of 10 you get something back that's just completely random, and like you just can't use it for production, right? Because it's like just not reliable enough. But I think it
sounds like what they say about me around the office. So, I mean, that would be.
Hey, 9 out of 10 not bad. That's why they keep you around, right?
That'll be an improvement. So something I hear a lot these days, and it's often tied to this discussion of AI, is NVIDIA.
Yep.
And I don't want to mention any names, but like Nancy Pelosi has made good money on NVIDIA, is one of many. I mean, it's something you hear about everywhere. Yeah, exactly. She's not the only one. I mean, do you think that this is a market that NVIDIA has cornered and they're going to continue to, or do you think that there's some other products like, I don't know, Halo out there that are?
So I think what you've seen is people emerge that are competitive on the inference side. So you have training of the models, which are these NVIDIA GPUs or large cluster like the H100s. NVIDIA is dominant there, and you've got AMD and others trying to catch up in like the training space. And then on the inference side, NVIDIA used to dominate inference. So, training, and then inference is the, running of the model. So you build the model, very time intensive, and then you deploy that model, on other devices for inference. So NVIDIA used to be used in both places. But what you've seen are inference specific chips like Halo, which we use and quite happy with. Very very high performant, low power. Great SDK for us to use. So you got stuff like Halo. You've got these NPUs that you're seeing pop up from Intel that are built into the higher end CPUs. Intel just released is it Arrow Lake? I think is the latest one that's got a higher end NPU. Meteor Lake had like a smaller one. AMD chips have it in there. The new Qualcomm that launched in the Windows tablets had that AI coprocessor. And then so you've got these inference only chips that are designed to run the models, whether it's a computer vision model, a video analytics model, LLM. There's a lot of competition in the inference space today, and NVIDIA I think has intentionally not really dug in there and focused their efforts more on the data center space, which I believe for them is higher margin. If you have fewer customers to deal with, if they had infinite capacity, they would probably try to dominate inference as well. But with limited fab capacity, they're I can't believe I'm saying NVIDIA is limited with stuff. They feel like they're just unstoppable at this point. But NVIDIA themselves will focus on the data center space. The question is, will there be companies like AMD and others that emerge to compete there? I think what's kind of what could be more interesting and what's the really the big risk for people heavily invested in NVIDIA is what if there's better ways to do AI that's not just heavy matrix multiplication, like doesn't map well into the GPUs. Like what if something better comes out and now all of a sudden I can go train my models 10x more efficient, and everyone just shifts business to something new. So I think it's the things that we don't know about today, I think, are the biggest threats to NVIDIA's dominance versus Intel, AMD, and others chipping away. So it'll be interesting to see if more interesting advanced training techniques come out that maybe the GPU is no longer the best way to do it.
Interesting. I mean, obviously, Intel is one that comes to mind when we talk about that subject of reshoring.
Yep.
And no doubt for me, I live in Columbus on the west side. Up on the northeast side of town, they're building that huge facility that's been pretty highly touted. I mean, do you think that's going to help them get back in the game here and chip away at what NVIDIA is doing? Or do you think that they're going to be a little too distracted by trying to rescale here, locally in the U.S.?
So, these are, long-term, design projects, right? Like, building a simple chip is still a couple year process. Building an advanced chip, like something that would compete with an NVIDIA GPU, that's a, multi-year project. So, Intel's been focused on reshoring manufacturing capability. So the question is, have they invested enough in the R&D for the AI processors themselves to be able to compete? I think manufacturing is only part of the problem. Intel has always been one of the leaders in chip manufacturing. So for me, it feels like it's more of a product design, engineering design issue for Intel versus a manufacturing one, and AMD as well. AMD's had, I'd say, pretty good silicon in this space to do data center type training. What's lacked up until very recently has been the tooling around using those chips and deploying models. So like one thing that NVIDIA has done quite well is not only focused on the hardware, but really developed the SDK, done the whole training ecosystem. I think AMD is starting to put more focus there, and it has a good chance to catch up. And then again, the ones that people like us probably aren't aware of are these new companies that are working directly with Microsoft or Google or others that are building custom chips for the hyperscale players that want to have another option to NVIDIA, but they also have the internal resources to build the software to use it. So I think that's what you're going to see is some interesting hardware that gets used by people that we don't get to touch because they've spent 3 or 4 years developing the software alongside this new silicon. So I think short term NVIDIA is going to stay dominant. Just they've done a great job. You have universities getting students familiar with the NVIDIA SDK, the NVIDIA tool chain. So it's like by default, you do anything with AI, it's like, oh, of course I'm going to use NVIDIA. Like that's where you start from, and that it's what we did as well, right? We started using NVIDIA stuff and then realized, okay, there's some smarter ways to do it, but like to be able to build and deploy a model that runs on NVIDIA versus, trying to build and deploy it and on, it's more of a, an edge AI, whatever. It's a bit of a lift and shift experience, and you've got to have some expertise to do it. So it's not just hardware, I guess. Long way of saying it's not just the hardware, the software needs to catch up as well. So it'll be interesting to see.
No, it's really interesting because I think if you ask somebody what they would say about NVIDIA in the general public, boy, is that different than what they would have said 5 or 6 years ago. I mean, it used to be they were really just kind of known for video cards and gaming machines primarily. And, it sounds like they had a real strategy and a real process to kind of seed themselves, through these various institutions over the long term. And now NVIDIA is seen very differently. I mean, I don't even think people associate them with video cards the way that they used to. I mean, it's almost shocking to me when I get my update on my gaming PC. I always forget that they still do that. But no, I mean, it's very, very interesting. So, all right. So I always like to end on kind of a fun question. So no expectations here if this is truly your area of expertise or not. But a few months ago, we had Pierre Bourgex on, who is he's worked with NSA and Secret Service and all kinds of stuff on the federal space, cybersecurity. Mm-hmm. And I asked him the question, what is it that no one's talking about that they should? And I don't know anyone else smart enough to even opine on this, so I'm just going to pick on you. His theory was that quantum computing was this capability that was sort of looming in the shadows that the general public's not thinking about. And he felt that cybersecurity will be null and void once quantum computing comes online. He had a lot of concerns there, which I thought was fun and I enjoyed. So, I mean, what do you think about that? I mean, do you think quantum computing is this big dragon in the cave that we're not paying attention to and is going to come out and just totally take over? I mean, it seems to me like it's a very expensive process. I can't imagine there's very many countries that could even afford to get involved with this. But
I think it's similar to what you're seeing with like the big AI companies, right? Where you need tons of capital just to even play in this space. From the cybersecurity just gone good away. It sounds like he watched Sneakers a bit too much when he was a kid, right? The whole no more secrets thing. You saw the movie, you got it. But like, okay, quantum resistant algorithms are being developed. You've got a lot of cases where, if you're doing security right, you're not even like you're depending on, data segregation, or, you don't even have the data to be able to decrypt. So like, I don't think all cybersecurity goes away, or some algorithm is going to, potentially have issues. Sure. Like, but I don't think it's going to be like, tomorrow, encryption doesn't exist anymore kind of thing. Like, there may be some spot cases here and there, whatever. The interesting thing with quantum is, maybe it's the smarter way to get to AGI, right? Like, instead of just kind of brute forcing it. Okay, now we've got, again, I'm not an expert here as well, but like it's a bit more magic to me than like, what we're doing today. So like, I guess maybe part of it's like hope that this is the path towards AGI that requires something more magical, at least magical to someone like me versus.
But when you say that, you're thinking not that, I mean, when we get into quantum, I don't know if anybody watched Devs, but first of all, I now have hope to live forever after watching that show. Maybe quantum will bring that. But I mean, I think what I'm hearing is you're wondering if maybe once we further scale this quantum computing, that maybe that will unlock the keys that we need to create this AGI.
Potentially,
using
right?
that quantum.
Yeah. So, quantum doesn't make everything faster, but for certain problems, it is much more efficient, right? So I view it as, quantum's not going to replace all kind of computing, but it may be deployed to accelerate certain things. Just like, GPUs aren't used for everything. They're used for certain parts of computing. So again, not an expert here at all. But
sure.
It's definitely some promise with specific algorithms. I don't think it's going to make security go away overnight, but it is one of those things where nation states are the only ones that can really play here, or heavily financed companies that typically have government partnerships. Like, you've got a handful of people developing these quantum computers. Google's heavily invested. the progress is made every day, but general purpose use, it's 10 years out. It's 10 years out. It's 10 years out, right? Like I don't think it's going to be one of those things that we see mass deployed in our lifetime, but maybe I'm wrong.
Who even really plays in the quantum space right now? Do we know that? I mean, obviously the United States. I mean, is it like China? Is it Korea? Like who even?
It's going to be the same ones that have the ability to invest in these large AI companies. So you're looking at U.S., you're looking at China, looking at Europe, parts of Europe. So yeah, it's significant cash needed here. And then the challenge here too is not just the hardware, like everything else. It's a whole other software paradigm, right? So.
Do you have any concept of like how are we using quantum now? I mean, aside from some TV shows I've watched and a book some Jack Carr books where there's an amazing AI that helps him fight, terrorists.
So
it's all fantasy. I mean, how are we actually using this? Is it just being researched? Are we actually using it? Or
so my understanding on the latest is using some of these machines to like run simulations much faster. So like, weather simulations, map well into quantum. So I think they're being used to, show that these algorithms can be accelerated quantum, but like the number of qubits in these systems is still so low. So it's like more like a proof of concept showing that, okay, this algorithm with, this very tiny quantum computer does show that it's going to actually be faster than doing it traditionally once we get the quantum computer actually built and fast enough, right? So I think we're still in this, again, my understanding is we're still in this, kind of research proof of concept phase. And the quantum computers themselves hasn't been scaled up enough to actually be useful, right? Where it's still faster to brute force something on traditional computers with a large cluster than using a quantum computer because, it's just, you can make it work. But, I'm guessing there's, larger quantum computers out there that you and I don't know about. So who knows what's actually being used? Just the research that's public that I've seen, it's still feels very much POC that has a lot of promise that will hopefully pay off over the next 10, 20 years.
I mean, my personal assumption would be, not to be conspiratorial, probably our Defense Department would have access to one before anyone knew it was being used and would use it for, intelligence and other purposes like that.
Yep. I agree. What typically happens.
But it feels like with, the AI we have now is really, I guess, putting a hurting on our power grid. We need to continue. I mean, are we going to have to run a jumper cable to the sun? If we do quantum and mass, I mean.
Well, even before AI, like even like just the hyperscale, Google, Microsoft, like even then, like power was a concern. And with the super dense, AI processing, it's just becoming more so. Like when I was doing hyperscale data center stuff, like a single rack would be like 10 kilowatts. And that was considered very dense for the time. Most data centers were like 4 kilowatts in a rack. Now you're getting something like 200 kilowatts in a single rack. So just like the energy density needed now to support these data centers is just orders of magnitude bigger than what it was just 10 years ago. So yeah, the power footprint.
I mean, I've seen a lot of science fiction movies that, they use nuclear reactors for power in the future. And, boy, I hope maybe somebody will invent that. Well, Chris, that was super fascinating, and thanks for playing along. I know quantum's not your main thing, but
I wish I had more time to research and look at it.
You are the closest thing to a quantum expert I'm probably ever going to get to speak to. So thanks for humoring me on that. Just give your operation a quick plug here. I mean, what type of customers do you work with, and how would they find you?
Yeah, so find us at deepperception.ai first, get that out of the way. We work with VMS manufacturers, NVR manufacturers, and integrators. So our model really is to partner with people who already have customers in this space, who already have products in this space, and really build the right solutions for your existing customers. So we can white label hardware. We can deploy our software on, co-locate it with the VMS itself. Like we're systems guys. So we will build systems that work with your existing systems. And, from analytics use cases, we're not too proud to do the basic ones, like just the basic object detection stuff. I think that's what really the demand is in the market, line crossing, dwell time. But we also have the capabilities to do more advanced things. And kind of our view on how things are going to evolve is people are going to buy modular AI appliances where you can have an appliance run, let's say 32 channels of simple AI or 8 channels of more advanced AI. And depending on what you need for a specific site, you maybe deploy 2 of these appliances or 4 of these appliances. So these are things that scale up and down, and maybe are replaced at a greater cycle than definitely the cameras, and a greater probably a faster pace than the VMSs. AI technology is evolving quickly. Similar to how you don't buy a new house. At least most people don't buy a new house every 2 or 3 years, but you get a new iPhone every 2 or 3 years. I see kind of AI analytics being that same thing, where it makes sense to be on a faster replacement cycle.
Sure.
Just because the technology is improving so quick. So we're open to work with partners in the space. We've got integrations to one of our very close friends and partners already that we will be launching soon. And we're working on integrations into the other open ecosystem players and others. So the typical Milestone, network optics, and the people using network optics, and that's we built our platform to be super quick to integrate. So if it's one of the open ones, we can do it. If you've got your own custom NVR, it usually takes us a couple weeks to build an integration. So that's what we're shooting for.
Yep. We got some exciting things that we're working on together that will be announced, at a later date, but they are great to work with. If you're out there watching, so give Chris a call and be very nice, because when the robots take over, Chris may be our conduit to a better future. Please tell them that my family and I will be very compliant, and we will do as the robots say.
Or just have analytics so the robots are coming at least. So we can help you with that.
I like it. Fight fire with fire. I mean, don't tell the robots I said that, but yeah, I'm totally in on that. Well, Chris, thanks a bunch, man. It's definitely one of the more fun episodes we've had. I mean, I just think it's a really great topic, and it's awesome to have somebody on that's actually got some knowledge on the subject, because otherwise I'm listening to Joe Rogan and it's Skynet this and Skynet that, and I'm not sure that's very accurate. So a whole lot of fun. We'll put your contact information, of course, in the description for anybody that wants to talk to Deep Perception and Chris and his team, and they're doing great things. And for the rest of you, thanks so much for watching, and we'll see you again very soon. Peace.